A handsome guy has beautiful fiancée gone for cinema. Collect all first small letters of each word. A, H, G, H, B, F, G, F, C. Write one below the other. A, H, G, first row, H, B, F, second row, G, F, C, third row. Interestingly, first row is equal to first column, second row is equal to second column, third row is equal to third column. It is A transpose is equal to A, which is known to be symmetric matrix. Let us suppose D is equal to determinant of that matrix A, H, G, H, B, F, G, F, C, which is a handsome guy has beautiful fiancée gone for cinema. If you find out the determinant of it, D is equal to ABC plus 2FGH minus AF square minus BG square minus CH square. Do you know? A second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents every geometrical figure in two-dimensional geometry. How? Let us go through that. But before that, understand to write in the substitution h is half of the coefficient of xy, g is half of the coefficient of x, f is half of the coefficient of y. Let us see that. First one, a point. It is to represent a point, a second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. To represent a point, D is equal to 0, A is equal to B, H is equal to 0, G square plus F square minus C equal to 0. It's a point circle. Next, straight line. For a straight line, D is equal to 0 and the second degree non-homogeneous equation must be a perfect square. Next one, pair of straight lines. D is equal to 0, h square greater than or equal to AB, G square greater than or equal to AC, F square greater than or equal to BC. Next, circle. D is non-zero. A is equal to B, H is equal to 0, G square plus F square minus C greater than 0. Next is parabola. D is non-zero, H square equal to AB. Next, ellipse. D is non-zero, H square less than AB. Observe carefully. Only for ellipse, there is no clash. If H square is less than AB, it is compulsory an ellipse. If you observe carefully, all the above 3 points, straight line, pair of straight lines, D is 0, and the below 3, circle, parabola, ellipse, D is non-zero. Hyperbola and rectangular hyperbola. If you see the first two conditions, D is non-zero, H square is greater than AB, then it is compulsory a hyperbola. If it is to be rectangular hyperbola, A plus B must also be 0. Let us see these questions now so that you will have more clarity while answering the questions. How I formed these questions by considering what conditions and what concepts I formed these questions. I will explain you so that it will be very much useful to you while answering the questions in your examinations. Let us see that. If you see the first one, x square plus y square minus 4x plus 2y plus 5 equal to 0. See this carefully. It is x square minus 4x plus 4. That is x minus 2 whole square. It is y square plus 2y plus 1. Y plus 1 whole square is equal to 0. That is x minus 2 whole square plus y plus 1 whole square equal to 0. It is nothing but 2 minus 1. I made the point circle. Point is 2 minus 1. So it is a point. Coming to the next one. 4x square plus 4xy plus y square plus 4x plus 2y plus 1 equal to 0. If you see this carefully, I have taken 2x whole square plus y square plus 1 square. That means rest all terms will be got by 2x plus y plus 1 whole square. So 2x plus y plus 1 whole square, if you square that one, you will be getting this. So it is a perfect square, and for this one you get d0, and it is a perfect square. It is a straight line. You can call it as pair of coincident lines, And coming to the next one, 4x square plus 4xy plus y square. I changed this xy terms and constant here, and you can see the homogeneous part is same. When the homogeneous part, you can see h is 2 here, and a is 4 here, b is 1 here, h square equal to ab, then it is parallel lines, please. These are parallel lines. But only thing is, it is a perfect square. It will not be perfect square. When it is not a perfect square, it represents a pair of parallel lines. These are pair of coincident parallel lines. These are pair of parallel lines. For this d0, for this also d0. I have just carried away the homogeneous part and changed the non-homogeneous part. I made it a pair of parallel lines. And coming to the next one, 4x square plus 4xy plus y square plus 6x plus 3y plus k equal to 0. Just observe it. This 2 only changed here. And I said k is not equal to 2. When the constant is changed, your determinant, that is a handsome guy has beautiful fiancée gone for cinema, will never be 0. So d not equal to 0, and observe h square equal to ab. H is 2 here, a is 4, b is 1. H square equal to ab, d not equal to 0. It becomes a parabola. That's how I formed it. Next one. Same equation, but I made some changes to y square here, y square coefficient here, 4x square plus 4xy minus 3y square plus 6x plus 3y plus 9 by 4. I adjusted the constant in such a way that it becomes a pair of intersecting lines. And if you find out d for this one, obviously d becomes 0, and h square is greater than or equal to ab, g square is greater than or equal to ac, f square is greater than or equal to bc. Then this becomes a pair of lines, and for this one, don't forget your d must be 0. Now, if you observe the next part, I carried the same equation. Just see that 4x square plus 4xy minus 3y square plus 6x plus 3y plus p I wrote, and p is non-9 by 4 I said. P is non-9 by 4 means if it is 9 by 4, your d becomes 0. Determinant becomes 0, but for any non-9 by 4, this determinant will not be 0. D not equal to 0. And what is h square here? 4. And what is AB here? Minus 12. So h square is greater than AB. D not equal to 0. It becomes a hyperbola. Like that. I formed it. Next one. 4x square minus 15x. I made some changes to the homogeneous part here such that it can be factorized. It will have rational factors. So you can see 6x plus 3y carried as it is, and I adjusted this equation in such a way that it represents a pair of straight lines only, but pair of intersecting lines only, but coefficient of x square plus coefficient of y square equal to 0. When coefficient of x square plus coefficient of y square, that is 4 minus 4, 0, it represents a pair of straight lines but perpendicular to each other. So pair of perpendicular lines, for this also d0, and the same equation carried to the next part, but only this constant changed here. I said r is non-370, this is r not p. R is non-378 by 289, and if it is changed, constant is changed, your d is not equal to 0 here. D is not equal to 0, and h square is greater than AB. What is h square here? 15 by 2 whole square. And what is AB here? 4 into minus 4. It is minus 16. So h square is greater than AB. D not equal to 0. And coefficient of x square plus coefficient of y square is equal to 0. It becomes a rectangular hyperbola. So this is a rectangular hyperbola. Coming to the last one, very comfortable one is the ellipse. For ellipse, no need to think of anything here. Like if you see, this is h square is 4 here and AB is 8 here. H square is less than AB, and you can comfortably say, without finding D, you can comfortably say it is an ellipse. That's what it is. You try this on your own, and you will be more comfortable in this part of two-dimensional geometry. So like this, every second degree non-homogeneous equation represents every geometrical figure in two-dimensional geometry under these conditions. This is what you have to understand.